Next, we want to look at some problems that involve some mixed units like hours and minutes, pounds and ounces, things like that. See if we can't do some conversions and then also a little arithmetic with these types of numbers. Here's our first problem. I have convert 4 hours 30 minutes into all minutes. So what I'm going to do for this problem is start by writing this as 4 hours. And I want to end up converting to just minutes, so I'm going to multiply 4 hours by one of my conversion factors that's going to let hours divide out and let me keep minutes. So I want this conversion factor to be the same as the number 1, so I'm going to say there's 60 minutes in 1 hour. Now that will allow these to divide out, so for my 4 hours, this converts it into minutes, and then I want to add on over here my 30 minutes. Okay, so I have 4 times 6. 4 times 60 is 240 minutes plus 30 minutes. That's going to give me 270 minutes. So when I convert 4 hours 30 minutes into just minutes, I get 270 minutes. And I have to do it this way. I take my hours, I multiply by the number 1. This conversion factor I know is the number 1 because 60 minutes and 1 hour are exactly the same thing. So I have the same number in the numerator and denominator. That means I have the number 1. But it's set up in such a way that I'm going to divide out my units of hours here, be left with minutes, so I can take minutes, add to minutes, because they're the same kind of units, and end up with 270 minutes. Here's our next one, or our next part of that one. Let's do the same problem, but convert everything to hours. Well, I have 4 hours, plus I have 30 minutes. So I want to convert my 30 minutes into hours. Again, I'm going to multiply by some conversion factor that's going to allow my minutes to divide out and leave me with hours. Again, I want this to be the number 1. So how about 1 hour and 60 minutes like this? My minutes divide out. 30 times 1 is 30 divided by 60 is going to give me 0.5. So I have 4 hours plus 0.5 hours. That will be 4.5 hours. So either way we do it, we're still using our conversion factors and multiplying by the number 1. I do it in just the right way. So if I want my hours to divide out, I have the fraction written the way that we'll do that. If I want my minutes to divide out, I have the fraction written the other way, so the minutes will divide out. Let's look at a problem now that involves pounds and ounces. I have convert 3 pounds 4 ounces to just ounces. Well, I know there's 16 ounces in every pound, so I'm going to write this as 3 pounds. I'll use this little notation for pound, times, okay, I want my pounds to divide out, and I want to be left with ounces. So I know there's 16 ounces in every 1 pound. That means that this is the number 1, but I've set this up in such a way that my pounds divide out. Then I'll add to that my 4 ounces. So I have 3 times 16 is going to be 48, plus 4 is going to be 52 ounces. So the trick to this problem, or not the trick, but the way you go about this problem is with a conversion factor here that's equal to the number 1, but that is set up in such a way that you get rid of the units that you're looking to get rid of and keep the units that you want to go to, in this case ounces. Let's look at the same problem, but let's convert all to pounds. Okay, so I have 3 pounds plus 4 ounces, and now I want to convert ounces into pounds. Well, again, I'm going to multiply by a conversion factor that's going to have ounces in the denominator, so those divide out, and pounds in the numerator, so I end up with pounds. Again, it's got to be the number 1, so I know 16 ounces is the same as 1 pound. The numerator and denominator are the same, so this is the number 1. My ounces divide out. 4 times 1 is 4, divided by 16, that's going to be 1/4. If I write that as a decimal, 0.25. 3 pounds plus 0.25 pounds, this will be 3.25 pounds. So that same quantity, 3 pounds 4 ounces, can be written as either 52 ounces or 3.25 pounds. Either way, all 3 of these numbers have the same value. Now let's look at another problem. I want to add 8 feet 10 inches to 13 feet 6 inches. So I've written the problem like this. Let's go over here into the inches column. I'll add 10 inches and 6 inches. That's going to give me 16 inches. Then I'll move over here to the feet column. 8 feet plus 13 feet is 21 feet. Now, I don't want to leave the problem like this because this is more than 1 foot, because there's 12 inches in a foot, so I have 16 inches here, so I've got 1 foot there. Just to write it all the way out, just so you can see it, this is going to be 21 feet plus 16 inches is 1 foot plus 4 inches. And so 21 feet plus 1 foot is going to be 22 feet plus 4 inches, 4 inches. 22 feet, 4 inches. So I add in the columns, I add inches, I get 16 inches. Over here I add feet, I get 21 feet. I notice that I have more than 1 foot here because there's 12 inches in 1 foot, so I have to write that little conversion if I want. Maybe I just think this step right here and don't actually write it out, end up with 22 feet, 4 inches. Okay, let's look at our next problem. I want to subtract 2 hours, 35 minutes from 8 hours, 15 minutes. Let's set this up vertically. I want to subtract this amount of time from this amount of time. So let's write this as 8 hours, 15 minutes, subtract 2 hours, 35 minutes. Okay. So I go into this column to try to subtract minutes. I have 35 minutes. I want to subtract that from 15 minutes. I don't have enough minutes to do that. So what I'm going to do is I'm going to borrow 1 hour over here, and that 1 hour is going to be 60 minutes. I've already got 50 minutes right here. Let me borrow an hour, which is 60 more minutes, and I'll add that on to this. So just as a notation that shows me that I've done that, instead of 8 hours, I'll have 7 hours, plus over here I'll have another 60 minutes. So there's my 1 hour that I took from here that I borrowed. 60 minutes plus 15 minutes is 75 minutes. Now I'll subtract 35 from 75. I'll end up with 40 minutes. So remember, this is 60 minutes plus my 15 minutes that I had originally. That's 75 minutes. Subtract 35 minutes gives me 40 minutes. Now I move over here. 2 hours subtracted from 7 hours will be just 5 hours. So I end up with 5 hours, 40 minutes. So kind of a nice exercise there in subtraction where I have to borrow 1 hour, which is the same as 60 minutes. Now, one more problem I want to do. Maggie rides a stationary bike for 1 hour, 15 minutes, 4 days each week. After 2 weeks, how much time has she spent on the bike? Well, this is going to involve multiplication. I'm going to find the number of days that she's ridden the bike in 2 weeks, and I'm going to multiply that times the number of time she spends on the bike each day. Let's take a look. So each day she rides the bike for 1 hour, 15 minutes. So 1 hour, 15 minutes. And then she does that 4 days a week. After 2 weeks, well, she's going to have ridden the bike 8 days. So I'm going to multiply this times 8. So if she rides 4 days a week for 2 weeks, that means she's going to have ridden the bike 8 times. So I'll take that 8, multiply that times the amount of time she spends on the bike each time she rides, and see what happens. Okay, 8 times 15, let's see, 8 times 5 is 40, so that's 120 minutes. And then 8 times 1 hour is 8 hours. Okay, so I have 8 hours, 120 minutes, or 8 hours plus 120 minutes. Well, I know there's 60 minutes in every hour, so 120 minutes must be another 2 hours. So this is 8 hours plus this is 2 hours. Now I have the same units here, so 8 hours plus 2 hours is going to give me 10 hours. So if Maggie rides this stationary bike for 1 hour, 15 minutes every time she's on it, and she's on it 4 days a week, in 2 weeks she will end up having been on the bicycle, the stationary bike, for a total of 10 hours. So that's a look at some problems that involve mixed units.